Okay, welcome to this video. This is the video of the practical you did on Friday. I don't think we've got time to do these in class, so I think I'll make videos of practicals now and the common things you're making mistakes on. Anyway, this practical is from, I'm just looking here, it's from 2021, that's the year. It is the May-June paper, and it is variant 3.1. So if you want to look up the mark scheme, you're more than welcome, and that's it. Okay, there you go, make it nice. All right, so first of all, before we do anything else, let's have a look at this stuff here that we barely read, most of us, I'm sure. When reagents are selected for use in the test, the name and the correct formula of the element or compound must be given. So, for example, if you're going to add barium nitrate, okay, aqueous, or barium chloride, they do the same thing, aqueous, you've got to say one of these things. So you've got to say, like, for example, barium chloride. Okay, what you can't say is barium ions. Okay, you can't do that. All right, I know it looks like you should be able to, but you can't. So you can do this, but you can't do that. All right, so anything other things we got to do? Color changes. Now, from whatever the color was to, okay, from brown to colorless or whatever. Now, when we're doing colors, we've got to use the colors themselves. Now, a solution is colorless, okay? It is never clear because all solutions are clear. So lots of you are still doing this. You can't use the word clear. All right, I think you mean to say colorless, but you don't use clear, something we've drummed into you since Form 4. Next, you've got to do the formation of a precipitate and whether it's soluble in an excess or not of the reagents. Next thing, we've got to do gas. You've got to identify any gas by a suitable test. And lots of you don't seem to know when to do this. If you heat something, there's a very good probability of a gas being given off. If you add an acid, you might want to test for a gas. Obviously, there's a gas if you see effervescence. Okay, so please check for gases. You indicate clearly at what stage in the test a change occurs. There you go. If a solution is warm, we've got to use a boiling tube. Okay. If you heat a solid, we use a test tube. If we heat a liquid, we use a boiling tube. So the small one is called a test tube, and the big one is called a boiling tube. We should all know that at our ages. If you finish the ones you're given, you've just got to rinse them out. So first of all, you rinse out with tap water. Okay, and then after that, you use the final rinse with distilled. Okay, there you go. And you don't do additional tests for ions present should be attempted. You shouldn't do anything more. The only thing that might confuse you here is you've got to test for gases, and they don't necessarily tell you what tests to do, but you've got to use your common sense and test for the most appropriate gas. Okay, ammonium thiocyanate, this stuff reacts with iron 3 ions to form an orange or red coloured compound. Iron 2 ions do not react in the same way. The darker the orange or red colour, the more the iron 3 ions are present in solution. For each test, use a 1 centimetre cube depth of Fa1 in a test tube. Record all your observations. Now, Fa1 is iron 2 sulfate. So it's got Fe2 plus ions in. All right, and as it just said above, iron 2 ions do not react. So if you've got the iron 2 sulfate, there it is, in a test tube, okay, and you add the colourless solution of ammonium thiocyanate, okay, it's not going to do anything, basically. All right, what it will do, if this has any colour to start with, it will just dilute the solution. That's all it will do, okay? Now, I'm looking at the answer scheme here. I've got it right in front of me. So what were you expected to say here? Okay, so actually, I haven't got the mark scheme. I did have it, but I've got it now. Okay, so you were supposed to say no visible change. Okay, that's probably the best answer. However, this stuff here, the iron sulfate, had a bit of a very pale colour to it anyway. And there may have been some oxidation in here. So there may have been the odd Fe3 plus. It's supposed to be just Fe2 plus in here, but it may have oxidized a little bit and you'll get some Fe3 plus. So what was also accepted was if you thought there may have been a change, you should have written something like this. You get a very pale orange colour. Okay, why would you get that? Well, because it's likely that some of the Fe2 plus would have been oxidized to Fe3 plus by the atmosphere. So you could have said either no visible change or a pale orange colour. Okay, both are worth 1 mark for this. Now add a few drops of aqueous sodium hydroxide, all right, and leave for at least 2 minutes. This is where the majority of us lost the mark. Okay, now this was very straightforward. Okay, what you get is you get a green precipitate. Okay, now some of you said you get a blue-green precipitate. Okay, now look, I don't know what you saw. Obviously, you did the test, but blue-green is not one of the options, is it? On the back, it's not on the analysis sheets, is it? So don't put blue green. Make it clear it's green. How do we know it's green? Well, because it's on the analysis sheet and it's Fe2 plus. You should know it's green. Okay, so you get a green precipitate. All right. Now with all of these things, you should. It does say just add a few drops here. So in this case, we don't need excess. Okay, it just wants you to add a few drops. Now what happens is this: you have your precipitate, there's your solution, and it's the green precipitate in here, green PPT. And this is where I think everyone missed the mark. You're supposed to leave it for 2 minutes. And any time you do something with Fe2 plus, it will undergo what's called atmospheric oxidation and you'll get Fe3 plus. It's always going to happen. And it's going to happen around the top of the test tube. Okay, so what we find, do I have a nice brown colour? Not really, do I? What's the closest? None of them really, this kind of colour, I guess. At the top, you'll see it turns a brown colour, and the brown colour is due to the oxidation. Okay, so what you're supposed to say after a few minutes, and very few of you went back to this, green precipitate initially, okay, precipitate turns brown at the surface. Please bear that in mind in future. This is a very particular, obviously, to Fe2 plus and Fe3 plus. Okay, and that would have got you a mark. Add dilute sulfuric acid, okay, drop-wise, that means drop by drop, until there is no further change, okay? So if you add sulfuric acid, what do we get? Let me get a nice colour here. Let me get this nice blue. What you get is, very simply, the precipitate dissolves. Okay, keep it clean and simple, okay? And the precipitate dissolves to give an orange brown solution. Okay, lots of you aren't saying what happened to the precipitate. And if you remember, let me pull this down. You've got to say, where is it? You've got to say what's happening to the precipitate. You've got to. Okay, if you say there's a precipitate in one answer, you've got to say what happens to it. Either it is soluble or it is not soluble. In this case, it was soluble. Okay, so the precipitate dissolves to give an orange brown solution. Then we added some ammonium thiosulfate. Now, what happens now? The solution goes to, well, I did this myself. You get a blood red. It's very, very red. Okay, it's blood red if you don't like that. It's deep red, okay, solution forms, because now the ammonium thiocyanate is reacting with the Fe3 plus ions. So you get a blood red or deep red solution. But one thing they say, you've got to say somehow it's more intense than test one, colour in test one. Now, don't forget, in test one, we said it was pale. Okay, which is fine. If you said that, that's good. But now we have a deep red solution. It's more intense. So what was the marking on this then? Let's have a look. Let's use black for this one. This one was worth 1, as I've said. This one was kind of worth a half, and this was worth a half. This was worth, I think, a half here, and this was worth a half. Anyway, in total, it was worth 3. But many of you just dropped a mark there. Okay, please look at what I do here and try and do something similar. Now, this is obviously the next page. Suggest a reason for any difference in observation when you added aqueous ammonium thiocyanate in test 2 compared with test 1. Your answer should refer to the type of reaction that occurred. Now, there was no reaction in test 1, but there was a deep red in test 2. And it says it. It said that you'll get the deep red color when you have Fe3 plus ions. So basically, whoops, Leslie, you should mention something like in test 1 there was no Fe3 plus ions, but in test 2 there were lots of Fe3 plus ions. So basically, we'd say something like this. Let me get a nice pen. This one, test 1, there were no Fe3 plus ions to react with the ammonium thiocyanate. Okay, in test 2, there were Fe3 plus ions had been formed, and therefore that's why we get the reaction. Yeah, and this reacts and gives. Let me put it in red, and these ions give red with ammonium thiocyanate. Okay, that was why. Now, obviously, and all of you should know what I'm going to come to next. Well, the Fe2 plus, if it goes to Fe3 plus, it's obviously an oxidation because the oxidation number increases. So, and it wanted that, didn't it? It said your answer should refer to the type of reaction. Now, you could have perhaps made this better than I've made it, and that's no problem either. You could have put it all in one package and said the Fe2 plus ions were oxidized to Fe3 plus ions in test 2. All of that says everything you need. Okay, it wanted you to say why. Okay, because you've got lots of Fe3 plus ions in now, and then it wanted you to mention the type of reaction. Very few of you did this nice and cleanly. All right, now the charge on a thiocyanate ion is -1. What's the formula for ammonium thiocyanate? Well, NH4 is ammonium, it's +1. SCN is -1. They're obviously going to be in a ratio of 1 to 1. So the formula for this guy is going to be NH4 SCN. That's it. Solution containing Fe2 plus reacts with aqueous ammonia to form a green precipitate. Write the ionic equation for the reaction. Now, I don't think anyone got this right, or very, very few. Now, let's go back to some qualitative analysis, or qualitative. I always get those mixed up. All right. Now, let's have a look at some solutions. Let's have a look at Fe2 plus in solution. And let's have a look at some Fe3 plus in solution. And let's have a look at some copper ions in solution. Now, I don't know what the other ion is. I don't care about the anion. I'm just going to pretend it's a chloride ion. Okay, we got solutions here. Let me do the stoichiometry correctly. There's 3 of those and 2 of those. So the first one is FeCl2. Second one is FeCl3. And the third one is CuCl2. Okay, now let's pretend we don't know what the cation is. Now don't forget, all of you, the cation is the metal ion. Okay, and the anion is obviously the non-metal ion. Non-metal ion. How do we test for cations? What we do is we form the hydroxide. Okay, and why do we form the hydroxide? Well, generally speaking, hydroxides are insoluble. Okay, and from its color, from the color of the hydroxide, we can tell what the cation is. Okay, so how do we find out what the cation is? Like from Form 4, how do we do this? Well, I haven't used that color before. All right, we add sodium hydroxide. We add sodium hydroxide, and we add sodium hydroxide. Okay, now because iron 2 hydroxide is insoluble, we get precipitate of iron 2 hydroxide. Because iron 3 hydroxide is insoluble, we get a precipitate of iron 3 hydroxide. And because copper 2 hydroxide is insoluble, we get a precipitate of copper 2 hydroxide. Now, why is that useful to us? Well, iron 2 hydroxide is a green, even though I'm writing it in this color, green precipitate. Iron 3 hydroxide is a brown precipitate, and copper 2 hydroxide is a blue precipitate. The colors we get in qualitative analysis are the hydroxides. It's the colors of the insoluble hydroxides. I don't think a lot of us seem to know that, all right? But it's the colors of the insoluble hydroxides. Now, why? Because they're insoluble, that's why they precipitate out. Okay, and then one of the tests we've just done above, that's why you get a green precipitate, because there's Fe2 plus ions in the solution, and it forms a green precipitate of iron 2 hydroxide. That's why you get these colors. Now that's sodium hydroxide, all right? But what about ammonia? Well, let's have a look. Let's pretend we've got the same solution here. In this case, I've got Fe2 plus ions, all right? And why not put my chloride ions there as well, just to make it the same as the above. Now, when I add ammonia, what happens? What happens with the addition of ammonia? Now, all of you should know this from periodicity. Okay, here we go. Ammonia, this stuff is aqueous. It reacts with water, and it forms a reversible reaction. It gives the ammonium ion and the OH minus ion. So when we add ammonia to things, all right, when we add this, we're basically adding hydroxide ions again. Okay, now why do we use sodium hydroxide and ammonia? Well, because in ammonia, the concentration of the hydroxide ions is low. Okay, and believe it or not, with a low concentration, you can figure things out. All right, that you can't do with a high concentration. Okay, that's why you get different effects with low concentrations. All right, so basically, then, if I add ammonia to this ammonia solution, now we say NH3 plus, but we're actually adding ammonium hydroxide. Okay, so I should say NH4OH. But it's not the ammonium ion that does anything, it's the hydroxide ion. So it does exactly what it does with the NaOH. So we have Fe ions in solution. They react with the hydroxide ions from the ammonium hydroxide, and you get the green precipitate again. And this is a green PPT. So the ionic equation here, I hope you will get something from this. The ionic equation for this is Fe2 plus aqueous, because it says you got to include state symbols, plus OH minus aqueous gives me the precipitate of FeOH twice solid. Now, obviously, you need a 2 there to balance it, but that's what they wanted. That's the ionic equation that we need. Okay, please learn those for everything before the exam. All right, then, so that's that page. Let me pause the video and go on to the next bit. Okay, this is the last page. This one, actually, you didn't have that much of a problem with it, but very few got 7 marks on this thing. Maybe the first question is a bit mean, but we shall see what you think. You can tell me if you think it's mean in a minute. All right, Fa4 contains 1 cation and 1 anion, so it's 1 cation. Where are we? 1 cation. There's a cation. I don't know what it is, but I test for all cations with sodium hydroxide and then I test it with aqueous ammonia. And why? Because we get the insoluble hydroxide, and we get the insoluble hydroxide. All right. Now, why do we do one and not the other? Well, as I said, you have a low concentration here and you have a high concentration of these. All right, and the other thing is the anion. Okay, and we're going to test for the anion. Now, if you use the qualitative analysis sheet, as you were given, what you know is the Fa4 contains sulfur. So Fa4 contains sulfur, so it's either the sulfite, whoops, 2 minus, isn't it? Or it's the sulfate. It's either one of those two. Simple as that. And if you look at the analysis sheet, it's dead easy figuring which one is out. I'll come to that in a minute. Okay, so the first thing you must do before you do anything, you've got to prepare a solution of Fa4 because you were given it in the solid and you've got to prepare a solution of Fa4. So in other words, add Fa4 to distilled water. You should have all done that to start with. Now you might think, oh, that's a bit unfair. Well, maybe not, but there's nothing we can do, is there? So you prepare a solution of Fa4, and now we've got to draw a table. Now, let me see. Try and make your table nice. You get 1 mark, by the way, for drawing a nice table. Okay, so let's draw a nice table. Your tables, most of you got a mark for this, so I'm not worried about that. There's that. And let me move this down a tiny bit. My table is not going to be great. Oh, yes, let me make a nice table. Okay, I can make a nice table because it's a video. All right, so we do that. Oops, you don't see. There we are. Now I'm going to draw a nice line down there. Oops, let me try and make it look pretty, eh? Okay, and now I'm going to move it over there. Whoops, it's harder than you think using this ruler. All right, so let's draw a line down here. It's about there-ish, I'm going to say. Okay, and now I'm going to put a line, I don't know, about here. Okay, and I think that's it, isn't it? Yeah, I think that's it. Right, now I'm going to do some horizontal lines. Obviously, I can see my lines at the bottom aren't great. I'll try and fix that in a minute. So let's look at that. Awful. Oh, the first two were good. Right, I'm going to draw a line here. Whoopsie daisy. Okay, that's good. I'm going to draw a line up here. You learn to draw these tables very quickly. Not like, obviously, this is taking ages for me. All right, so I'm going to do 2 tests on my cation. I know what they are. Okay, one of them is sodium hydroxide, and one of them is ammonia. And there's about there, isn't it? There. And I do a line there, something like that. Oops. And there you go. I've drawn a nice table. Get rid of the ruler. Try and get rid of that nasty little thing there. Oops, there's a bit more, tiny bit more. Oof. There. Oh, that's good enough for me. All right, so let me draw what was I going to do in here. Let's do it in red. So on the left, I'm going to say the test. What's the test? And this is the observation. By the way, we get 1 mark for this, just saying make a solution. So there's only, and there's there's 6 marks available in the for the table now. Then isn't there? I think I can't remember. All right, what's the test? Right, the first test is we're going to add sodium hydroxide. I know I'm going to do that because I'm testing for a cation. And the second test, because I'm testing for a cation, I'm going to add aqueous ammonia. So that's that. Now, what you should have got, I don't know what you've got, but what you should have got for the first one, you get a white precipitate. Now, in A level, you've got to add to excess without being told to. Okay, and what you should have found there is adding to excess, you get insoluble in excess. You should have got that. All right, ammonia, when I added the ammonia, what did I get? I also get a white precipitate because it's the same thing, by the way. I get the hydroxide. White precipitate, and what now? insoluble. You should have got insoluble in excess. Okay. Now, from those two, you should have figured out very simply that the cation is, what is it, magnesium. Okay, simple case of using the sheet. Okay, so there you go. Very straightforward, nothing hard there. Now, if I look at the analysis sheet, how do I test for the sulfate and the sulfate ion? What we do is we add barium chloride, aqueous. Now, you could add or barium nitrate. Okay, it's the same stuff. It either adds the barium ion, but you can't say I add barium ions. You've got to pick one or the other. All right, and what do I get when I add this? I add, well, sorry, what do I get? I get a white precipitate. Now, that doesn't help me because sulfate and sulfite will both give a white precipitate. So the second test for this is we add a strong acid. Now, the strong acid that we generally use in chemistry is HCl. Okay, all right. Now, if the precipitate dissolves, it's this one. If it doesn't dissolve, it's the sulfate. And what you should have seen was the precipitate. Oh, let me do it nicely. You've got to mention what happens to this precipitate. Precipitate does not dissolve, or something to that effect, or insoluble. Precipitate is insoluble in excess HCl. Okay. Now, knowing those two things, it means the anion is a sulfate ion. All right. So there you go. And look at the table. It's not very complicated. Lots of you overcomplicated the table. Okay, make it simple. It's very simple. Use the analysis sheet. All right, I'm going to stop it there. And please tell me if you think this is useful, because I'll do more for practicals if you think it is.